Okay, now look at this. Okay, so we are continuing with similarity. So we have already done the trapezium and all. So now the next thing is an exception sum. So what happens when the lines are not parallel? So this is an exception. So every time the question that we did earlier was where we had questions where the lines were already marked parallel like this, the lines are marked parallel, but now we'll be talking about questions where the lines are not marked parallel. So let's take one figure at a time. So we take the first figure, that is this figure. So over here lines are not marked parallel. So the first thing we need to know is if the lines are not marked parallel, so we cannot use corresponding angles. Normally what we were doing is we were always using what? We were using this angle was equal to this angle. When we were writing corresponding angles, we were saying this angle equal to this angle. They were equal to each other, corresponding angle. We separated and we wrote this equal to this, and then we wrote this equal to this, and once they are similar, automatically the third pair is equal. But now we cannot use corresponding angles. It's corresponding angles will be applicable only if the lines are parallel. So lines not parallel, we cannot use corresponding angles. Okay, but we still will need two pairs of angles equal to each other to prove triangle similar. So if I have to somehow prove the small triangle and the big triangle similar, where the lines are not parallel, I will still need two pairs of lines, two pairs of angles equal to prove them similar. But we cannot use corresponding angles. Is that okay? So we said we cannot use corresponding. So then what is the other option that we have? What is the other way by which we can prove similar if we cannot use corresponding? Then in this type of question where the line is not parallel, then what will happen is we need two pairs. I said the first pair, what will happen is you check or you read the question carefully. 100% what will happen is one pair of angle, the first pair of angle will be either marked or will be given to you in the question. That means they will say like maybe this angle and this angle equal, or this angle and this angle equal. Okay, they will mention that. Either in the question they'll write it like this angle equal to this angle, or they will mark it for you in the figure. So you just have to check, do I have any markings like that? Or if it's not there, then you have to read the question. 100% will be there if the lines are not parallel. Okay, and then the second pair, once I have this, then the second pair is I have to check for a common angle. Now how to check that, I'll come with an example I'll give you. But what is a common angle? Common angle means the angle which will be there in both the small triangle and the big triangle. So in this figure I'll have to check which is one angle which will be there in the small triangle also, which will be there in the big triangle also. Like for example is this one. This angle is in the small triangle also, whereas this angle is in the big triangle also. So this particular angle will be called a common angle. So we have to use these two pairs to prove our triangles similar. Okay, so let's go ahead and give you an example of that. Okay, so let's say this is the question and let's say it's already marked. I said if it's not marked, then it will be written like they may say given, they'll say angle ABC is equal to angle ADE. Like this they will give you in the question. Either this will be written or they will mark something like this. So right now for the time being it's marked. And then they're saying prove triangle ABC is similar to triangle ADE. So then first thing is I separate the small triangle and the big triangle. This is the small triangle, this is the big triangle, and they've already marked a B and E equal. So I mark B and E equal. And then I said, if you look at this carefully, this angle is in both the small triangle and the big triangle. So if you look over here also, so we have B and C, but there is no B and C, we have D and A. But if I look, A is here also in the small triangle, A is there in the big triangle also. So this angle is what will be the common angle. So when I have to write, I write like this. In triangle ABC and triangle ADE, I first write the given one. So I write ABC, that is ABC is equal to angle AED, and I write at the side. You don't have to write anything, you just have to write given. Why? Because it's already given to me in the question. Okay, and then the second one, that is BAC is equal to angle DAE, and the reason you'll write is you'll write common. So these are the two reasons. In the previous ones, when the lines were parallel, we were writing corresponding angles, but now one will be the angle that has already been given, another is the common angle, and therefore this triangle and this triangle is similar by angle, and automatically the third pair will also be equal. So that is ACB and ADE, ACB and AD equal. So then once I have the corresponding sides proportion. Okay, so now in a similar manner, let's talk about the second figure. Okay, where we're still doing an exception where the lines are not parallel. So where the lines were parallel in the previous ones also, what we are talking about is we were talking about alternate angles, but over here lines are not parallel. parallel, so we cannot take alternate, so we'll have to choose another method. So over here also, so we cannot use alternate, so it says we cannot use alternate angle to prove similar. So then what is the other option left? Then over here again, just like in the previous one, first pair over here also, like in the previous one, 100% will be marked or will be given to you in the question. So just like in the first type also, first pair will always be given. So in this type also, in this type also, first pair will always be given. Whereas the second pair over here in this one, the second pair was the common angle. But over here you won't have anything common. We'll have to use vertically opposite angles. And which are vertically opposite angles? Whenever lines cross each other, these two are called vertically. They are opposite to each other and they are always equal. Similarly, if I look from this point of view, then this angle and this angle are also equal if I look from this point of view. So whenever lines cross each other, we'll always have angles called vertically opposite angles, and they will always be equal to each other. Okay, so we will have vertically opposite angles that we'll have to use to prove the triangle similar instead of alternate angles. And when do we do this? Whenever lines are not marked parallel. Had the lines been marked parallel, then I would have said this angle and this angle, cone conic, would be equal to each other. This will be equal to this will be equal by alternate angles. Is that okay? So let's go ahead and give you an example, okay, of this one. Okay, so let's say it is this figure, and let's say like in the previous sum, this is already marked for us. If it's not marked, you read the question, it will be given to you in the question itself. Okay, so now in these two triangles, I can say in triangle ABC, so ABC means what? This one and this one, I have BAC is equal to angle CDE. Why? It's given. And then when the lines cross, I said these angles are vertically, so this angle and this angle, they are vertically opposite angles. Okay, and this name is ACB is equal to angle DCE. Reason is vertically opposite angles, and then the triangles are similar, and then the third angle automatically becomes equal to each other. So these two are called vertically. And now sometimes the figure may be rotated. So if I have the figure in this form, then vertically opposite will be this angle and this angle will be vertically opposite. So I'll say ACB equals to angle DC vertically. And sometimes I may have like this. So if it's like this, so instead of marking this and this like initially I've marked this, if I have the marking as this, then this mark means 90. So when I write, okay, and this already is vertically, so when I write angle, let's say I'll write angle BAC equals to angle CED, and the reason I'll write is it's given to you in the question, but since it's already marked 90, so write 90 degrees also. Please be specific. If it's a 90-degree mark, you write it as 90 degree, don't just write given. If it's a single, this like normal mark, then you just write given. You don't have to write 90, but if it's 90, please write a 90 also. Okay.